Hi everyone, do you hear me? Hi everyone, sorry for having the live event at the Thanksgiving. Next time I'll do better and figure out when there are different holidays at different parts of the world and try to make the event at some other time. But if you can make it today, don't worry. I'm recording the video and you will get the replay tomorrow in the email. We still have like 6 minutes to go. Maybe let's make it 8. So first of all, hello everyone, and if you want to say from where do you live, and maybe just a city would be enough. I'm from Krakow in Poland. Right now it's 7 p.m. almost here. And we don't have Thanksgiving, so that's why I can do this live event. So where are you from? I see there are 21 people already. I expect to be at least 50, maybe more, we'll see. To the right of the screen you should have a chat. Feel free to ask questions there. Oh, Mark is from Germany. Olga from Switzerland. Italy. Maynard, Massachusetts, nice. Nivagain, sorry if I don't pronounce cities correctly. From Netherlands, nice. And Denmark. Great to have people from different parts of the world. During the event today, I'm going to show you how to open borders on Commodore 64. So if you already know how to do that, I think you will have fun during the event, even though you already know that. I'll try to add some tidbits for advanced Commodore 64 programmers as well. But if you don't know anything about programming, don't worry, there won't be too much code. You will be able to understand everything. There will be a lot of hand waving, a lot of drawing. So I'll try to explain the principle, so then you'll be able to understand it and then code it yourself. Oh, nice. We have Canada, Warszawa from Poland, and Finland. Are there any advanced demo sceners here? Or not necessarily advanced, but is there anyone on the chat who made at least one demo or maybe one game for Commodore 64? In other words, just let me know what's your experience in programming Commodore 64. It's great if you have none. It's great if you are advanced programmer. Doesn't matter. I hope you did prepare something to drink and you are comfortable. Oh, not Olga says that not for Commodore 64, but one demo for another system. Which one? Oh, nice. Mark is slightly advanced, about 30 years ago. Nice. Just starting out, none, just playing games, lol. Well, I'll try to inspire you to change that. Hi, Tomasz. Oh, Jarosław, you started a Pong game for Commodore 64 but never finished. If you Google Sos Sosowski, the indie game developer, he has a pretty great example on how to do a Pong game, which fits on one screen. The source code is actually an image of the source code, but you can understand pretty much everything. We have a couple of minutes, so maybe I'll find it and I'll show it to you. Or maybe it won't be so easy to find. Let's see. Oh yes, I found it. I can show it to you. This should work. So if you go to this game, games.sos.gde, here is the Pong, which is the game for Commodore 64, which looks like that. And here you can find the source code, which fits on one image. It's pretty well documented, and it's a pretty great start if you want to modify it and try to understand the source code. Pretty great exercise. Let me catch up with chat for a second. We'll have like 2 minutes and we'll start. So does anyone have a specific, like what is your biggest challenge when it comes to programming Commodore 64? You can answer that question during the presentation, and afterwards I'll read it and I'll try to help you in some way. All right, I think we can start. So today in this live presentation, we'll be talking about opening borders on Commodore 64. Commodore 64 is a pretty old computer. For all those who don't know what exactly this computer is, you can see on the screen right now, that's the Commodore 64. Actually, that's an emulator of Commodore 64, which runs on my computer, which is a pretty great thing because right now we don't need to own the Commodore 64, the actual machine, and we can program on the emulators. I'll explain the emulator in a bit, but for those who haven't seen Commodore 64, it's this beauty. So this is the actual machine, and I think this one was built in '84, which makes this computer the same age, approximately the same age as me. So I'm 35 years old, and this computer is the same. And the great thing about programming Commodore 64 nowadays is that we don't even need to own the machine, because emulators, like the program that you see in the background, pretty much pretend that they are the actual machine, and they emulate not only the features of the machine, but also all the bugs, or at least most of the bugs of the machine. And that's actually a great thing, because there are a lot of bugs on Commodore 64 in the hardware that were exploited during those years and became features. Without them, Commodore 64 wouldn't be the same machine. And one of those bugs lets us open the border. Okay, but what does opening the border mean? If you look at the screen, we have this part of the screen here. So this is the border. It was designed this way because back then we didn't have LCD screens, and the image was displayed on cathode ray tubes television sets and monitors, and there was it was not that easy to make sure the actual size of the visible display. So on some TVs you could see probably something like this, and on some TVs you could barely see the border. So that's why, just to be sure, the border was added to Commodore 64 and some other computers as well. And Commodore 64 basically has the display of 320 by 200 pixels, which is this part, not counting the border. And it can display either characters or bitmap graphics in this part of the screen. And that's basically it. But if we somehow manage to open the border and somehow make it disappear, then we are able to effectively increase the resolution of Commodore 64. And we can use a couple of tricks to achieve that. But to know these tricks, we need to know a couple of other stuff first. So let me show you on the whiteboard. So basically this is the same image. So this is the border. This is the part that you can draw on. You can type characters here. And normally we have 40 by 25 characters on the screen. And Commodore 64 is not able to display anymore. So that's the one thing. The other thing that you need to know about Commodore 64, even though it is an old computer, it already had something like a graphical card. So right now we have, on modern computers, we have CPU, and we have graphical cards like NVIDIA or AMD, and they are responsible for displaying graphics. So because the CPUs are not optimized to draw beautiful 3D landscapes, that's why we have graphical accelerators and graphical cards that are specializing in doing that. And back then, Commodore 64 had something like that. It had a graphical chip that was designed to optimize display of graphics that was maybe not revolutionary, but it was like on the it had some great features that were popular back then. So it couldn't display like 3D worlds, but it could display movable graphics. Those things were called sprites, and they could be displayed on any part of the screen immediately. They could be moved through the screen, and they could be displayed. They could be used to display, for example, characters in a game. And Commodore 64 could display 8 those sprites. And the great thing about sprites is that they are fast, because like CPU on Commodore 64 is pretty slow, and if you would like to copy the bitmap from one place to another without the help of the graphical chip, that would take a lot of time, and we wouldn't fit the rest of the code of the game in every frame. So that's why Commodore 64 has a graphical chip, and this graphical chip can display 40 characters, 40 columns, and 25 rows of characters on the screen. The other interesting feature of the graphical chip is that it can move the screen around by 8 pixels max. So it's called hardware accelerated scrolling, and at any point in time, by changing one value in the memory that is tied to a special register of the chip, we can move the screen on the vertical axis or on the horizontal axis by up to 8 pixels. And this has a problem. This is one problem, because if we move the screen down, so if we have here letter A and here letter Z, and we move it by, let's say, 4 pixels, so those letters will become cropped. So this is Z, and the lower part of the Z is invisible, and those letters will be moved down. But here, above those letters, we will see something that we haven't seen before. And this is part of the screen that was previously hidden behind the border, and now because of the screen scrolling, it is now visible. And designers of the hardware had a problem, because they couldn't fit more bitmap memory, or they couldn't manage to design a chip within the budget that could handle more memory, so they couldn't add additional row of characters, and they couldn't add additional column of characters. So instead they decided to add a feature to Commodore 64 that allows the Commodore 64 to enlarge the border. So if we change another value in the memory that is tied to another register on the graphical chip, we can make the border wider. And so that's the result, is that we have the smaller screen. So instead of showing 40 by 25 characters, right now we would show 40 by 24 characters. And we can do the same thing on the horizontal axis, and then we have 39 by 24 characters. And those things are necessary to understand the trick to opening the border. Let me look at the chat and see if there are any questions. So do you understand everything here? To sum it up, Commodore 64 has a graphical chip and that has a couple of different features. It can show sprites and it can scroll the screen, and because of the tight budget of designing the graphical chip, they couldn't fit more characters into the memory, but they could enlarge the border, allow us to enlarge the border to hide the stuff that shouldn't be visible. Let me know if that's clear in the chat. If you don't understand something, just write it on the chat and I'll try to get back to you. So right now, we know that there is a feature that allows us to enlarge the border. Maybe I'll do that. Oh, right now it will be easier to see that. What's interesting at this moment, what we want to achieve is to make the border disappear. And to make it easy, we can focus on the top and the bottom border. So we want to achieve something like that. So there is that there will be no border at the top and the bottom of the screen. So here would be the end of the drawable area. And here the area behind the border could be visible. That's the end result. And when we achieve that, we would be able to somehow draw on this part of the screen, but not with bitmaps, because they can be only drawn in this part. But we can, for example, display sprites. So we can add a movable bitmap here, add a movable bitmap here, and display something there. So we could, for example, display multiple sprites here and try to pretend that we have letters here, or something like that. Or we could add some, enlarge our game board and add some sprites there. Well, possibilities are endless, but the idea is if we manage to get rid of the border, we can display something here using, for example, sprites. Okay, so how to open the border? First, we need to understand how the Commodore 64 or the graphical chip of the Commodore 64 decides when to draw a border. The image on Commodore 64 is generated in rows. So let me draw the border first. So the image starts on the top, and the graphical chip tells the monitor which pixels it should draw. And basically it goes row by row from the top to the bottom. And the important thing is that Commodore 64 knows at which line it currently is. So, and the greater and even better is that we can get this information. And there is a special place in the memory where we can ask the Commodore 64 about the current line number. And basically, there are two places on the top of the screen that are interesting to us, and two places at the bottom of the screen that are interesting to us. So let's say this is the place where the border is in a normal state. So this is the normal size of the border, and this is the normal size of the border, and this place is the enlarge border. So this is the one that we enable when we scroll the screen to hide what's beneath the border. And the thing is, Commodore 64 doesn't check if it should draw the border at every line, at least when it comes to top and the bottom part of the border. It goes like that. It draws the screen up to this part, and it checks the special register that controls if we should display the white border or not. and checks it here. And it checks if the border should be displayed as in the wider mode. If yes, then it still draws the border up until this point. And here it checks again. Basically it stops drawing the border. And also the same thing happens here. When Commodore 64 goes to this place on the screen, it checks if it should start display border. And if yes, then it starts displaying a border. If no, it goes to this part of the screen and checks if it should display a border again. And the trick is to figure out that we are in this part of display. So we can ask the Commodore 64 on which line are you currently displaying the screen, and we can wait until we are about here. And so at this point, let's say we are in the normal mode. So at this point we display the border here. So when Commodore 64 goes to this part, it asks if we should be in the wide border mode. And the answer is no. We are supposed to be displaying the normal border. So 25 rows of characters should be visible. So if that is the case, then Commodore 64 says, okay, I won't start drawing border at this moment. So the border disappears from here. And now we have time to act. If we are here and if we manage to run a part of the code that switches the register that is responsible for making the border wider, then Commodore 64 goes to the second place where it checks if the border should be turned on, and it sees that the register is set. So it assumes that, well, if I'm at this place and the border register is set to be wide, well, then I probably done that before. So it doesn't start it doesn't even begin to display the border here. So basically we wait with the changing the border wideness at this moment, and because of this trick, Commodore 64 doesn't start opening the border yet. And then it displays the rest of the screen, and on the next frame it goes here. So right now the border is not being displayed, so this part of the screen is not being displayed, and then it goes to this place and it sees that the border is in the wide mode, so it's the border is in the wide mode. Oh, so it doesn't do anything here, because like if the border would be in the normal mode, then it would stop displaying the border here. But if it comes here, it stops displaying a border, and it switches the special flip in the graphical chip. And when it does that, on the next frame this trick won't work, because we need to do the same thing again. So the thing is that on every frame we need to wait until this moment to make the border wider, and then before the next frame happens, we need to switch the border again so that the computer thinks it displayed the border actually. It will be a bit easier to follow when I show you the code, which will be in a second, but let me know in the comments if that's understandable. Okay, seems to me that everyone follows up till now. So let me show you a couple of things on the screen. This is the source code for all of the lessons that I recorded about Commodore 64. So if you don't know, so basically that's my history. So when I was younger, I got the Commodore 64 from my grandpa, and not this one. This is the one that I bought like 6 years ago or so. That one is long gone, unfortunately. And I always wanted to figure out how the stuff that I've seen in demos and games work on Commodore 64. And I wasn't able to figure it out until much later. Around 2013, a couple of years ago, I decided it's about time to learn the assembly on Commodore 64 and figure out the secrets of those demos and secrets of those games and how all those cool tricks worked. And when I was learning that, I decided to also teach people the things that I learn. And that's why I created the 64 bytes, and I'll tell you about it after this part. But basically it's a series, I recorded a series of videos that focus on one specific thing, for example, opening the border or maybe screen scrolling, and tries to compress all the knowledge into a 5-minute episode and gives you the source code, the transcript and exercises. So let me show you an example. For example, we could see something about sprites, maybe sprite animation. So this is the source code for animating some sprites, loading them on the screen, and basically this is the source code in assembly. If you don't understand what you are seeing right now, don't worry, I won't be going into too much detail. But basically you can compile the thing on your own computer, and it will generate the program that can run on Commodore 64, the real one, or that can run in the emulator. And this one runs in the emulator and displays two sprites. One is scaled up and both are animated. Here is another one with animating sprites. This one loads them from the other program, from the sprite pad, and displays them on the screen. And I wanted to show you one part of one episode when I showed the hardware scrolling. So let's see what this one does. Oh, so this is the example of the effect that I was telling you about. If you move the screen up, you will see what's behind the border. So this black part is the part when you cannot display any bitmap data, at least not with characters, and it's usually invisible under the border. And the code to move the screen up is the part that actually moves the screen up should be pretty easy. Yeah, it's probably this one. So it basically changes the screen control register that is responsible for not only for that, but also for the position of the screen. And if we set part of the register to the value from 0 to 7, then we move the screen by 0 to 7 pixels. So this one shows how to animate the same stuff. So here we can see that the scrolling feature can be used to animate the whole screen, which works pretty fast and is much faster than if we would try to copy the contents of the bitmap. That would probably be mostly impossible on Commodore 64 if we've done that on the CPU. And this part shows the example that makes the border wider. So right now we don't see the black part of the screen, and this is the feature that can allow us to scroll the screen and without any unwanted artifacts. So once we know how to open use the border enlarging register, then we can start working on opening the border. So I recorded an episode on opening the border that starts with a really simple code that has nothing and a loop. And I created a simple macro that waits for a specific raster line. And I show you what it does. So this is the part of the code that does something like that. I need to add a bin folder, sorry. And not make syntax errors. So here I added some code that marks this part of the screen when we start and finish opening the border. So it works like that. We wait until last raster line number 50, then we change the border color register by -1, and then after a couple of cycles we bring back the border color register to the previous value, which results in the thin bar that is different color. And then we wait until the first part of the bottom border, and then we do the same thing to display this thin line in a different color. And this macro to wait for the raster line is actually pretty simple, because we pass a number, then we load the value of that number into the accumulator, which is one of the registers of Commodore 64, and then we compare the value, which is the line 50, with the value of the VIC2 raster line register. which is just a place in the memory at the address D012, which is mapped to a specific register of the graphical chip. And this register tells us the number of the raster line. So we compare those two numbers, the number that we are interested in, which is 50, and the number of the actual raster line. And if they are not equal, we wait. Actually, we jump to here, and then we try again and again and again and again until the lines are equal. So the line 50 and the current raster line is 50. So then we continue. And this is part of the code that checks for line numbers that are greater than 255. But in our case, that is actually not needed. So we could delete that code and it would still work. So basically we wait for the line number 50. And once we reach that line, we continue, and this part of the code can happen. Let me see on the chat if you understand it. Let me know if that's clear. Cool. So we now know where the border in the normal mode ends. So this is line 50 and line 252. So now we go to the 24 rows mode, which makes the border wider. And we do that by clearing the 4th bit of the screen control register. And that's it. If we clear this bit, the border is wider. If we set this bit, the border is normal. So right now we enable the 24 row mode, so the screen should be smaller and the border should be wider. And if we run this code, we can see then that is the case. And here I also marked those two places. So this is the normal length of the border, and this is the wider part. And here the same. This is the wider part, and this is the normal border. So the trick to open the border is to feed the code somewhere here between those two lines. And we have plenty of time to do that because there are plenty of cycles that are available to us. So we can wait until the line, let's say, anywhere between lines 247 and 251, we can place some code that does the opposite of that. Well, that does actually that, and then somewhere later we need to do the opposite. And in the episodes I show a couple of experiments because we don't only are able to open the border, we can close it completely or maybe make the screen wider at the top and leave the screen the same at the bottom. So here we can see example of making the screen I don't see it right now, but one of those examples just makes the screen wider at the top and thinner at the bottom. The other one does the opposite thing, and we could also use this code to make the screen disappear completely, so tell the computer to display the border all the time. So in this place we can see that here we display here is the code, what I'm doing here. Oh, so before we go into this place here, we make the border normal, and then in the middle of the screen we make the border wider. And we can try some different experiments and try to make the border wider and thinner between different parts of the screen. But finally, something interesting happens. Oh, in this part of the screen, we make the screen disappear. So we tell the computer, well, don't stop drawing the border. But that's not really interesting. There are easier ways to do that. But the most interesting part is what we do in the last experiment. Oh no. In the last experiment, when we finally make the border disappear. And how does it happen? So basically this is the raster line when the border is wider at the bottom. This is the raster line when the border is lower. And we wait until this part of the raster time happens, and somewhere between those two raster lines we need to make sure that the screen control register has this bit cleared. If it's cleared, then it means that the border is wider. So when the computer starts to render this line and it checks the screen control register, it sees that, well, the border is wider, so I think I already enabled the border while I was here, so I don't need to do it again. All right, nothing to do. And once it happens, the border is not being rendered at all. And on the next frame, we don't need to do anything until we are again at this line. Because right now, the computer thinks that the border is wide. And if the border is wide and it reaches this part, it will start drawing it again. So before that line is reached by the Commodore 64, we need to make the border thin. And it doesn't matter where we do that. We need to make sure do it somewhere before the line 247. So we can do it at the middle of the screen, and this is why I draw this line here, I think. Or maybe not. We can add some. We can see the background color. Change to see where exactly is that line. Oh, so this is the place where the code is executed. So somewhere here we make the computer think that the border was being set to wide mode, and here we bring it back. So when the computer reaches this line again, it sees, oh, the border is not being widened, so I don't need to enable it yet. I will do it in about 8 pixels. And then we switch it again, and then computer reaches this lower line, and it says, okay, so I already done that, I don't need to start drawing it again. And basically that's it. So that's the principle. Let me know if that is clear. So this is the principle that allows us to not only open the lower and the top part of the border, but it also allows us to open side borders. But opening side borders is much harder. The reason for that is the way Commodore 64 displays the screen. Because we are displaying the screen from the top to the bottom, we have plenty of time to execute this code and make this trick so that computer thinks it already started drawing the border, and then it thinks that it doesn't started drawing the border yet, and so on, so on. So we can do the same thing for the side borders, but because computer generates the screen row by row, we need to do this trick on every raster line. So the code to opening side borders is much more complicated, because not only we need to wait for this specific moment here to make the same trick, so make the computer think that it first doesn't need to display border yet, and then doesn't need to display border anymore. We need to do it on every raster line. And the hard part is we need to be exact to one cycle. The trick works only on the specific cycle of each raster line. And so not only we need to add some code on each raster line, we need to execute the specific thing at one cycle of the raster line, which means that we need to have our code synchronized to a specific position of the raster on the screen, which is much harder, because when we are opening the top and the bottom borders, we have plenty of time. We have multiple cycles between this part of the screen and this part of the screen. And those lines are not jittering only by accident. Normally, you don't have guarantee that your code is synchronized with the raster. And usually, what you see is this kind of jittering. Right, and there are ways to make the code stable. So in other words, to synchronize the code to exact raster position. And once we do that, which is one problem that we need to overcome, then we need to execute specific number of cycles and then flip the switch at exact time. And we need to do it on every line. And this is complicated because there are some other stuff. There are some so-called bed lines, which is the place on each 8 pixels of the screen when Commodore 64, where the graphical chip needs to fetch the bitmap data for characters, and it takes some time. So then on every 8 raster lines, we have less cycles to fit our code in. So we need to have specific part of the code for bed lines. We need to have specific part of the code for normal lines. And also, if we display sprites on the screen, they also eat up cycles. So yeah, it also depends on which sprites are enabled at the current moment, and it's not that easy. But it's possible, and I have a couple of other episodes. So one is about raster stabilization, which tells you how to make the jittering disappear every time, and a couple of episodes about opening borders. So those are about opening side borders, and finally opening side borders and also displaying sprites on the screen while the borders are open. So basically, if you do it here, if we compile this code, this should have open borders almost. So in this part of the screen, we have almost all of the screen opened, but except for those two lines. So this part should have everything open. So this is how you open the border, and the code is a bit more complicated than before because we need to do some specific stuff on bed lines, we need to do some specific stuff on normal lines, and so on and so on. The other thing that complicates opening the borders is displaying sprites. So let's say this one. So this one opens the bottom border. Now this one displays few sprites on the screen. And in the previous one, I'm showing that you can open the border, but in this one, when you display a couple of sprites on the screen, those weird things happen because when you display some specific sprites on the screen, they steal some cycles, and there is an algorithm that you can figure out, well, which sprites steal which cycles and so on, and it's pretty complicated. But when you get around that and you finally add some code that fixes this specific case, you can display sprites and then also open borders. And a couple of episodes later, we get to a point when we display many more sprites on every position of the border, and it also works. Oh, that's not in this one. Sprites everywhere should show a bit more sprites. So this is the Commodore 64 with both types of border open, the top and the bottom, and it displays much more than 8 sprites. So this is actually another part that was not unspecified on Commodore 64. So it's not that Commodore 64 can display only 8 sprites, but it can display up to 8 sprites on a single raster line. So if we manage to move those sprites before we reach another raster line, we can display them again, and if we change their bitmaps, we can display some other sprites. And here you can see some weird barcode on the screen, and this is actually something that we can somehow control. What's being displayed here is the contents of the last byte of the memory bank of the graphical chip, which is with a normal configuration, it's basically displays in the memory. Whatever byte pattern you will put into this place, it will result in the kind of a barcode. So let's see if we can change that. So right now we have 10110100, which results in the barcode. If we fill those things with ones, we'll see a different pattern. So this is how we can control a bit this part of the screen. Unfortunately, we don't have that much control over that. We could change it if we are fast enough and our code is stable enough. We could try to change it quickly and modify this part of the screen somehow. But well, it can be used for a pretty cool effects in demos, but it's not that easy to do. But it's additional way to display graphics in this part of the screen. So we could, when we open the border, we can either display some sprites there, or we can use this this special place in the memory and change it to some different byte patterns and try to display some kind of a bitmap in such way. Well, at least we can for example draw some barcodes and call it a day. But I've seen some pretty clever things, pretty clever ways of doing this, of using this part of the memory in a clever way. So one thing that's important, that we cannot control the color of this part of the screen. It's always black, and the other color is the color of the background. So if we want to display some kind of an image, it needs to contain the black. Yeah, so the question on the chat is, why sprites already? Why not show how to open the borders? It's too hard for me to show how to open side borders completely in during a live event. But if you know the principle, you can get around to that when you know the building blocks for that. So first thing that you need to know that that trick with fooling computer at the specific place on the screen. So the principle is the same, but opening the top border and the bottom part of the border is easier because we have plenty of time to do that. So if we get back to this opening the border, which was here. So once we know how to switch the border open, we can do the same thing on the side border. But the trick is, we need to first learn how to stabilize our code, so to synchronize with the exact position of the raster line. Then we need to know how many cycles our code needs to wait until it reaches the specific part here. And once we do that, it's pretty easy, because we need to execute one we just need to switch one bit in the memory at this exact cycle, and when we do it, the border starts to open. And the rest of it is just continuing opening the border on the rest of those lines. And if you see the episodes on opening borders, this is the part when we start doing that. But again, I need to add a bin. No, there is a bin folder. Oh, I have some additional bug in the code that won't work. Okay, so this is one line of border being open. And once we get there, it's not that complicated to continue. Basically, this is the code. We need to somehow stabilize our code to make it synchronized with the raster. Then we need to wait specific number of cycles. And then we need to make the border wider before, make the border thinner, so make the border normal before the exact cycle happens. And then we need to make the border wider at the exact cycle. So this part of, this is changing the border back and forth. So this is the same trick that we used before in the top and the bottom part of the border. But this is the part that waits for specific numbers of cycles that makes this code work. And that's it. When we do that, we can open another line, which works exactly the same. So first, we wait for the specific, first we stabilize our code, then we wait, then we do the trick, and we have one line open. Then we do the same thing again. We wait for another line, and then we do the exact trick again. So this part, maybe let's not break here. Sorry, live coding is always tricky. So this is like a couple of lines being open. And we just need to figure out how to do that for the rest of the screen. But the principle is the same. We need to wait, we need to flip the border to normal position, and then we need to flip the border to wider position. And that's it. We need to just do it on each line on the screen. And that's the principle. So that's why it's much easier to open the top and the bottom of the border, because we need to do it once per frame, but here we need to do it once per raster line. Oh, the question, what shows in the top bottom of the border when you're in high-res mode? So that was the part you were talking about, this barcode stuff. So this is what I explained before, which is the last byte of the Big Bang, which is here I calculated this part in the memory. Basically, it's the very last byte of the current memory part that is controlled by the graphical chip, and you can figure it out either by calculating it or by memorizing it, but basically it's just one specific place in the memory where you just need to put some bits, and then you can achieve some pattern. So you can have it, you can have some kind of a barcode. You can have it cleared. Or you can have it completely black. And that's it. You can do some other tricks with that, but it's much harder. And you can also display sprites. So here I'm just displaying static sprites. Here is the code that enables those sprites, basically initializes their positions, and that's it. So that is only to show that what we can do with the border being open. We can display sprites, and we can use this last byte of the memory bank and to put some pattern there. So if you are interested in programming Commodore 64, I would love to invite you to check my video series. Let me just switch the screen. Okay. So this is the series I created. The code that I've shown is the code that you get when you grab a video. So let's say which part. Let's say the video about opening the border. This is the opening side borders, and one of the first videos is opening border top and bottom. So basically this episode, it takes about 5 minutes and explains everything that I try to explain in 1 hour right now. It doesn't explain how to scroll the screen because that's a job for another episode that was earlier. And basically what you get with each of those episodes is the video, which usually takes about 5 to 10 minutes. And you get a full transcript for the video, which looks like that. Let me show you the screen again. So with every video you get the transcript. You also get the source code for each specific part of the video because it's only 5 minutes, but a lot of stuff happens there. And if you want to follow along, it's easier to just open the source code. This is the one that you start, which does nothing and just enters a loop. And then you fill it with some additional code that is explained on the video. And you also get some exercises that make sure that you understand what you've seen, and sometimes they force you to do something more. And this is the way to learn the stuff that is explained on the video. So the series can be consumed in the different ways, and it depends on how advanced you are on Commodore 64. And one of the ways is to start from scratch. So basically you can go to the episode page, and if you go to the bottom, there are more than 100 episodes, and they start from the very basic, from basics of basic. We start from BASIC, which is one of the programming languages. It is available on Commodore 64, but it's slow. So you cannot do any game or any interesting demo in that because it's slow. And if you want to do something serious on Commodore 64, you need to learn the assembly. But it's good to start with BASIC because when you turn the computer on, it's on and it displays the basic input and you can start programming right away. So in the first few episodes I introduced the BASIC, and then we quickly jump into assembly. And then I introduce the Kick assembler, which is the compilator that I use to compile the assembly code into machine code that is understandable by Commodore 64. And the only tools that you need to program Commodore 64 is this thing. So this is the compiler, this thing which is the emulator, and this thing which is basically any notepad will work. But in the videos I use Sublime Text because it works on every platform and it's free. Speaking about free, you can check a couple of episodes. So for example, the one that explains to you how to set up all tools, you can get it for free. If you put 0 here, you will not pay anything for that. So you can add it to cart and then if you pass an email here, you will get this episode for free, and that's it. There are some other free episodes about testing, about more testing, about joystick handling, about high-res sprites, about using sprite pad, about stack, zero page, custom character sets, and high-res bitmap mode, so how to display beautiful graphics on Commodore 64. So if you want to see if that's for you, I invite you to check those couple of free episodes and download them, watch them, try to code with them, and see if that's something that works for you. You can also grab any of those episodes, which are now discounted, and every one of them costs only $2. But it's okay if you want to get just one of them or two. But if you want to get more, I would invite you to check seasons, which are just bundles of those episodes. Each season has 9 of them. And if you want to grab them all, it's much cheaper and much easier because you can take one. It's just $10, which I can't do right now because I did something wrong. Okay, you can add it to cart. If you want to buy all seasons, you can. The easiest way to do that is to add them all from this page to cart. And when you pay, you can, if you have a company, you can add a VAT ID here. If you are in Europe, then normally to the price we have to add the special tax. But if you have a company and you put the VAT ID here, you won't pay it. And you can, if you want to buy something for somebody as a gift, you can go to the site for the specific season, for example, and here there is no shopping cart, but you can click this part of the here and add some message to somebody that you want to send a gift. So right now, because of Black Friday, which is tomorrow, but I'm in Poland, so I don't really get this part because we don't have Thanksgiving and we don't really have a reason to have Black Friday, but because everyone does that, I always do something like that. So right now, every season and every episode is 50% off, and the discount ends on Sunday. So you have plenty of time to check those free episodes, maybe buy some single ones, and if you like it, buy everything, and I hope you love them. And if you do, I will have more incentive to do another ones and teach you more about Commodore 64, which I plan to do in the near future. There is other way that you can help me. If you don't want to buy those episodes, or if you don't like those episodes, well, if you don't like those episodes, then you probably don't want to help me. But if you like those episodes, but you don't want to buy them for some reason, or you can't buy them right now, it would really help me if you let your friends know about this series. Because I'm not very much known yet on the internet, and I would love to reach more people who love to program Commodore 64 and teach them how to do that, how fun is that, and then in the future produce more content for Commodore 64, and that's it. Also, while you're on YouTube, please subscribe to this channel, because I plan to put some more free content on the YouTube on this channel, in the future. So please subscribe and please click on this bell button so that you'll be notified by YouTube whenever something happens on the channel. Okay, let me see what's happening on the chat. Oh yeah, thanks for pointing out the address of the last byte of the VIC bank. It's 3FFFF but it's in a default configuration. If you move the VIC bank, then the last byte is at the different address. But in the default position, that's correct. Thanks. Jam MMO asks for a promo code. So the promo code is already included on the website. The promo code is, I'll write it on the chat, If you buy it through the 64 bytes website, the promo code is already pre-applied to every link. But if you do it directly from Gumroad or you happen to do something weird, then the promo code is BF19, like Black Friday 19. Oh yeah, the question about season 12. Yes, I'm going to add remaining episodes to the season 12, and if you buy or if you bought season 12, you will get them free of charge. And I'm long overdue to finish those episodes, but that will definitely happen next year. I would love to say that will happen before Christmas this year. I would love to give everyone this gift, but yeah, I'm not sure. I hope to do that, but they will definitely show up next year for sure. Do you plan to show some C128 specific code? How do you say C128 in English? That's the correct way to say it? I don't know. C128. I'm not sure. There are not so many interesting differences between those two computers, in my opinion. And I don't know that much about Commodore 128. But maybe I would love to explore some different machines, but Commodore 64 is the one thing that I grew up with, and that's why I focus on that. I'm also interested in, wait for it, in 8-bit Atari. Because I met a lot of people who grew up with Atari, and it's actually pretty interesting computer. The operating system, for example, is better designed than the system in Commodore 64, and it has a completely different set of things that people do on Atari. And the graphical chip is different and the sound chip is different, so it's a completely different set of challenges, which are also interesting. But for now, I'm focusing on Commodore 64, but maybe in the future something other will show up on the website. Oh, 128. Thank you for letting me know how to properly pronounce it. Cool. C128. Oh, do you do any programming on hardware? No, at the moment I don't do it, because right now I don't have any use case that would force me to use the actual Commodore 64 to do it. I used to check the border opening code, the side borders on the real machine, because there were some differences that I couldn't properly see on the device. But this is the one thing. Oh, the other thing that comes to mind, I recently bought some paddles and I want to do some code that uses them, and I haven't figured out a proper way to emulate paddles in the emulator. So this is one code that I will use the actual Commodore 64 to check if it works, definitely. So the question about how do I get further episodes of season 12. So if you already bought the season, whenever I release new episode, you will get an email that, hey, new episodes is added to your bundle. You can download it here. So don't worry, when it's released, you will be notified. Oh, so okay, I need to explain another thing. So this right now, the 64 bytes website is just a front side of the store. So you can only buy stuff here, and whenever you buy an episode or the bundle of episodes, so whenever you buy season or episode, it will be distributed through something that is called Gumroad. And Gumroad is a service that I use to host my videos and to sell my videos. It's not very user-friendly. Basically, whenever you buy an episode on 64 bytes, it will be added to your account on Gumroad, and there are two ways that you can access your episode. Either you log into Gumroad with the same email that you used to buy those episodes, or you check your inbox and then you have an email which contains a link to a specific episode or to a specific season. One of the things I would love to do next year is to create a platform that would host those videos in a much more user-friendly way. So what I would love to do is to create a system here that would allow you to log in and stream those videos online instead of being forced to look into your inbox and then try to find those episodes that you bought. So the way it works right now is not that user-friendly, but it works, and you can download all episodes and all the source code on your computer, and you can watch it on your computer. But it's not a Netflix-like experience yet, which is something I would love to do in the next year. Idea for new episodes, they are very good but very condensed. Wouldn't hurt if they took 5 minutes more if explaining things. So another thing that I would love to do, hopefully next year, is to create something separate from 64 bytes episodes. Because a lot of people want to have something that take them from scratch to, let's say, creating a game. Basically, something that you can already do when you grab a couple of 64 bytes episodes and then combine the code into a game. But right now you need to do it on your own, and by design those videos are really short and really condensed. So what I plan to do next year, hopefully, is to create some kind of a course that will allow you to start from scratch and create a game in a much more lengthy way than in actual episodes. But right now you can grab 64 bytes episodes and try to do that on your own. And once you get some experience, it gets easier. For example, I use my videos in the following way. So I don't remember For example, the whole memory map of Commodore 64. I don't remember how to exactly open the border. And for example, if I would like to create a game that had maybe split screen, I would find the episode that shows me how to split screen. I would find the episodes that shows me how to handle joystick. And I would combine those two episodes together, like take part of the code from the one take the other part of the code from the second one, and then I could create part of the game and have some code that would allow me to start creating some game. If you want to create a demo, you can get the code for example, raster stabilization, which allows you to do get rid of the jittering, and this in turn allows you to make some effects like opening border, displaying more than 8 sprites, and so on. So I find it that 64 bytes, the series, can be used by beginners by going through each episode from first to last one. Or if you're an advanced programmer and you don't remember how to do this one specific stuff, you can treat it as a library of techniques. And when let's say, when you want to remind yourself how to animate characters, you have episode for that. If you want to remind yourself how to, for example, how to use zero page, you have example for that. How to enable multicolor mode, extended background color mode, and so on. So advanced programmers treat it as a library that you can pick the example code and start from there, or just to remind yourself how to open borders. You just watch 5-minute video or read the transcript and you know again. So I do it all the time. I forget stuff about that I knew before. For example, right now, I have no idea how to play SID music, but I know that I can watch my own video and I would remind myself in a couple of minutes, and it works. But yeah, I hear you. I plan to do something that is not as condensed and something that takes you and explains concepts from scratch to some bigger project. Jürgen, so if you didn't get an email, I will send it to you after the live event. Oh, Tom asks me, how did you learn? Those old books are hard. Well, yes, that's why I'm here. So I read those old books, so you don't have to. Some of those things were not that hard for me. Like I have more than 15 years of programming experience. I'm a programmer. Like my day job was being a programmer. So some part of it was not that hard, but on Commodore 64 there are some quirks that you really need to read about, you really need to experiment with, and those things with opening the border and displaying sprites were probably the hardest thing that I managed to figure out and record a lesson. But yeah, that's true. Reading old books is hard, finding information on the internet is hard, and that's why you have me. I do it for you, so you don't have to. I usually learn from books, and I learn also from a couple of places on the internet. For example, there is code, I think it's called Codebase 64. It's a wiki that explains different stuff related to programming Commodore 64. So this is the alternative source of knowledge. It's a lot of source code here. Some of the things are not explained, some of the things are explained, but yeah, you can learn a lot from this website, definitely. The other place that you need to get familiar with is the Commodore 64 memory map. So this is the index of everything that is happening in the memory of the Commodore 64, which is important because that's how you interface with Commodore 64, by writing to the memory and by reading from the memory. So for example, 3FFF. So yeah, this is the last byte of the VIC memory bank by default. I wonder if it's somehow marked in the memory map. No, it's not. So yeah, this is kind of a secret place in the memory that you can use. But yeah, if you want to know how to move sprite number 0, this is the place that you do. You just need to write some value into this register to move it in the horizontal coordinate, and if you write any value here, you move it vertically. And that's basically how you interact with Commodore 64, by writing and reading values in a memory. Yeah, so mapping the C64 PDF is awesome too. It's even better if you have the physical copy, because then you can find stuff a bit more quickly. Okay, do you have anything else to ask, maybe not related to opening border? Do you have any challenges with programming Commodore 64? Just let me know. Let's say we finish in like 5 minutes, so if you have some last questions, fire away. If I missed your question on the chat, feel free to write it again. So those images that fill the screen completely in demos are mainly composed with sprites in those borders. It has nothing to do with bitmaps in the borders. That is impossible. Yes and no. So right now you cannot fill the whole screen with any pixel. Basically, if you open the border, it's not like that you can display any bitmap there. On the side borders, you can display sprites, you can lay some sprites on top of each other, and then you have get bigger resolution and more colors. But for now, it's not yet possible to put to make any pixel on the screen in any color. We are close to there, but not there yet. But every couple of years somebody figures out some weird hack and creates a new way of drawing images, so I wouldn't be surprised if something like that shows up. Oh, the question, will it work on modern the C64 re-releases? It should work on that, because as far as I know, the C64 is the hardware emulator coded in FPGA that closely emulates what Commodore 64 did. So yes, it should work in the same way that the code works on the emulator, on the device, for example. Some really obscure stuff might not work on the C64, but I'm not on that level. I couldn't code anything like that complicated that wouldn't work on the emulator yet. But I know people who do stuff like that, so yeah, not everything is possible, but for most of us, we could use this C64, we could use Ultimate C64, we can use the emulator, we could use the D64, not the C64 TV or whatever that the joystick was called, and yeah, it should work pretty much everywhere. Yes, I know about Ultimate 64. Somewhere here I have the cartridge, which has some functionalities. It's not the whole computer, but the cartridge itself is pretty cool because you can transfer files using SD card or USB stick, and it works. Yeah, I have 1541 Ultimate 2, and the recent version is, as far as I know, 1541 Ultimate 2 Plus. So yeah, I highly recommend this cartridge. It's great, and I think it also has the feature that allows you to connect your computer to the cartridge and then transfer the code directly into the memory, which sounds great, but I haven't figured out how to do that yet. So the Ultimate, the motherboard is not the only motherboard on the market. So if you're interested in that, there are some others that, for example, because Ultimate is kind of an FPGA emulator, so it's not a real Commodore 64, but there is also the motherboard that basically is a bit more energy efficient hardware that allows you to put the graphical chip, the SID chip, and basically you could have a modern Commodore 64 that works the same as the previous hardware. But yeah, I love everything that shows up on the Commodore 64 market, and I support everything that shows up on the market, because whenever someone does something that makes this beautiful machine live a bit longer, then it's great. Okay, let's say we have a couple of minutes for the last questions. Oh yeah, that's true. The name was Reloaded MK2. That's the name of the motherboard that allows you to have the old chips in this modern motherboard. Yeah, I agree. The unfortunate part is that you still need the chips, which are not produced anymore and are not yet completely disassembled. So are not yet completely reverse engineered, so we cannot yet create new ones, unfortunately. Oh yeah, that's a great advice on the chat. You can start with the owner's manual. There are some it's pretty great manual that shows you how to start programming in BASIC, and that's exactly how I started when I was younger. I haven't had any book about programming assembly, but I had a manual, and so one of the first things I did was to type 10 print Commodore 64, then 20 go to 10, and that was my first program. And then I learned how to display this sprite, which was a balloon with the Commodore logo on the side, and yeah, it was pretty cool, and it taught me a bit about programming, and probably it made me a programmer in the long term, because I loved to do that. Oh, I missed the question. Do you have any pro tips how to learn some programming on Commodore 64? So yeah, one obvious advice that I can give you is to go to 64bytes.com and start from the oldest episodes, because they start from scratch. So a couple of people already went through my series and learned how to program Commodore 64 by going through each subsequent episode, because they are ordered in such way that every episode built on top of each other. For example, I don't show you how to open the border before I show you how to scroll the screen. I don't show you how to display more than 8 sprites before I show you how to display one, and so on. So one way is to use 64 bytes because it's designed to be a source of knowledge for Commodore 64. The other way is to read some old books. If you want to learn more about Commodore 64 in about an hour, there is one great talk I've seen. It's called the Ultimate C64 Talk, I think. This one. You can find it on YouTube. It's called Ultimate C64 Talk. I'll give you a link. Because it's awesome. It takes exactly 64 minutes by design. And it tells you pretty much everything you need to know about the hardware and a bit about programming Commodore 64 and most important stuff. John Gilberto, I am not familiar yet with groundbreaking work of the C64 coder John Woods, but I will check what's this groundbreaking stuff. If you have a link, feel free to put it in the chat. Oh, nice. I will definitely check this out later. Thank you for the link. Okay, I think that should be enough. Tomorrow I plan to do short live event just for questions and answers for those who couldn't attend this one because they were like spending time with their family on Thanksgiving. So expect an email from me, and if you want to talk about a bit more about Commodore 64, I'll be available tomorrow around the same time, I think. But I will let you know in an email. Make sure to subscribe, and if you are not subscribed to my newsletter, just go to the 64bytes.com, and if you open the website and wait a bit, you should see a pop-up that allows you to subscribe, or you can click this link at the bottom of the screen and you can put your name and the email, and then I will let you know whenever I release something new, and basically I'll let you know about interesting stuff related to Commodore 64. Thank you all for coming. It was great fun, and I hope to see you some next time. Bye. See you soon.